And in this podcast, we're going to find out about the meaning of momentum and what happens when things collide with each other. So, Ben, scientifically speaking, what actually is a collision?
Well, when two things collide, there will be forces acting between the objects which will transfer energy and momentum between the two objects.
So what's momentum?
An object's momentum is equal to its mass times its velocity. So a massive, fast-moving object will have lots of momentum. If no external forces are acting upon an object or on a group of objects, their total momentum must stay the same. We say the momentum is conserved. For example, if you throw a stone, you're giving it a momentum, but the total momentum of you and the stone must equal the momentum before you threw it. Let's say that you weigh 60 kilograms and the stone weighs 6 kilograms. You start off standing still, so the total momentum of you and the stone is your mass, 60 kilograms, times your velocity, 0 meters per second, plus the momentum of the stone. That's 6 kilograms times 0 meters per second. That means the total momentum is 0.
But if I throw the rock, it should have a momentum, which is the mass times the velocity I throw it at. So how can the total momentum be 0?
If you throw the rock at 5 meters per second, it would have a total momentum of 5 meters per second times 6 kilograms, that's 30 kilogram meters per second. As the total momentum must still be 0, your momentum must therefore be minus 30 kilogram meters per second.
But how can I have a negative momentum?
Well, because it's velocity times mass, and velocity has a direction, a negative momentum is just momentum in the opposite direction.
How fast would I be moving in that opposite direction then?
Well, because momentum equals mass times velocity, we can divide both sides of the equation by mass to give velocity equals momentum divided by mass. So your velocity will be 30 over 60 is 0.5 meters per second. But you would only move backwards if you were on a slippery floor, on ice for example. Practically, there's so much friction between you and the Earth that we have to think of the mass as being your mass plus the mass of the Earth. This gives you a huge mass, and so the velocity will be tiny. You can do a similar sort of calculation on a collision between two objects, or on a gun firing. If you know the momentum of the objects to start with, you will know the total momentum afterwards.
And why is momentum important in a gun?
Well, at the start you know that everything is stationary, so the total momentum is 0. If a 10-gram bullet is fired in one direction at 100 meters per second, then it has a momentum of 0.01 kilograms times 100 meters per second, so 1 kilogram meters per second. If the gun weighs 2 kilograms, it will end up moving at 1 kilogram meters per second divided by 2 kilograms, so the gun will be moving backwards at 0.5 meters per second. We call this backward motion recoil.
OK, now in those last two calculations, things have ended up going back at the same speed, that's 0.5 meters per second, but a gun pushes back much more violently than that, doesn't it?
Well, when you fire a gun, the change of momentum happens very, very quickly, maybe in just 1/100th of a second. But when you throw the rock, the change in momentum took about a second to happen.
And why is the time important?
Well, you need a large force to change something's momentum quickly. So because the gun fires so fast, the force must be very, very large. In fact, the rate of change of momentum is equal to the force that is acting on the object.
So if I was moving at, say, 10 meters a second and I wanted to stop in 2 seconds, can you work out how much force is required?
Well, yes, we can. Your mass is about 60 kilograms, so your momentum at that speed is about 600 kilogram meters per second. You want to stop in 2 seconds, so if we divide your momentum by the time in which it's changing, we should find its rate of change and so the force. We get 600 over 2 is 300 newtons, so you need a force of 300 newtons for 2 seconds to stop you.
So the momentum gets conserved under circumstances like this, but what about the energy?
Well, yes, the total amount of energy is also conserved, but because there are lots of types of energy, kinetic energy can be converted into heat, or when you fire a gun, chemical energy is converted into kinetic energy, so momentum is actually a much more useful thing for working out what will happen in these situations.